Today we're going to start 6.5, the indirect proofs and inequalities in one triangle. There's really a couple different parts to this lesson, but the one that kind of is a little weird at times is the indirect proof or proof by contradiction. Okay, this on page 186 of your student journal, you actually have some notes on this, so you may want to take a look at those. I'll put those up there. Okay, but how to write an indirect proof or a proof by contradiction. I want you to read through those and try to figure out what it's saying. Make some notes to yourself. We'll go through it here in a second. So to write an indirect proof, you first have to identify the statement you want to prove, which is usually pretty easy. Kind of the weird part is you start assuming, you're going to assume temporarily that the statement that you're trying to prove is false. So if I say, hey, prove that this triangle is congruent to that triangle, or prove that parallel lines can never cross, then we're going to start by saying, well, parallel lines do cross. Okay? And then we're going to prove a contradiction in that. Okay? So as long as we can come up with one statement that contradicts it, okay, then we can prove that what we're trying to prove is true. Okay, it's kind of a weird way about going things, but reason logically until you reach contradiction and point out the desired conclusion. So these are our 3 steps. We're going to work through one of these. Kind of want to go through right now. So let's start with this guy right here. Example 1. All right, write an indirect proof that in a given triangle there can be at most one right angle. So you're going to prove that in a triangle there can be at most one right angle. All right? We are going to follow these 3 steps, though, to write an indirect proof on it. So the first thing we need to do, identify the statement we want to prove. Tell your neighbor what that statement is. Okay. Very good. Heard a bunch say that. That's what we're trying to prove. We are now going to assume that that statement is false by assuming that the opposite is true. So we're going to say that this is false by saying well, the opposite is true. So maybe an opposite statement here could be, rather than ABC can have at most one right angle, well, let's say ABC has 2 right angles. Okay, so let's start with that. Okay? I want you to explain to your neighbor how you know that this is false. That's our next statement. Our next step is to reason logically until you reach a contradiction. Okay? Contradict this statement using geometric reasoning. Okay? Go ahead and talk about it. How can you prove that that's false? Hey, anyone want to go through and tell me how they proved it? Go ahead, Isaac. Okay, so can I pause you there? So let's say A and B are my right angles. Okay, so you're saying, so they equal 90 degrees each. All right? And now what would you do from there? Oops. Okay. Okay. Everyone agree with that? Okay, so to write that up, I mean, we've done a pretty good setup here. We want to say, well, since measure of angle A plus measure of angle B plus measure of angle C has to equal 180, C cannot be, what would C have to be? Yeah. In this scenario, the measure of angle C would have to equal 0 degrees, which is not possible. All right, just so you know, I'm going to give you guys a handout with all this on here in a minute. So those of you frantically writing, I'm going to give you a whole handout, just even with this example on there for you. Okay? All right. Therefore, a triangle cannot have two angles that are 90 degrees. Okay? So by assuming triangle ABC has two right angles, we've been able to prove that that's false, meaning ABC can have at most one right angle. Okay? So our final, this will be the sheet I give you here in a minute, but kind of the steps you go through. Step 1, identify the statement you want to prove. Step 2, reason logically a contradiction. Then step 3, we want to point out the desired conclusion, which I didn't finish on there. But here's our, rather than using ABC, there's LMN. Okay? But the same idea. All right? We'll leave that up there. I'm going to pass it out and let you guys kind of read through what your final statement would be there. Hey, you got to thank Mr. Borek for this handout if you ever see her. She's the one that put it together. Very good. Yes?
So inside the example, it uses theorem. Do we need to mention English theorem?
Well, I mean, it mentioned the theorem because triangle angle sum theorem says 180 degrees, but I would have been fine if you just said, I know that the sum of the angles of a triangle is 180.
So we don't necessarily need to.
Correct. Yeah. Okay. Hey, any questions there? All right, I want you to try this one. Write an indirect proof that a scaling triangle cannot have more than two congruent. Ladies and gentlemen, good question. You cannot just say by definition of a scaling triangle that is full. That's true. You can't do that. Okay? So, hey, let's first assume that a scaling triangle can have two congruent angles. That's our first step. Okay? So let's assume, after we've found what we're trying to prove, but let's now assume a scaling triangle can have two right angles, or two congruent angles. Okay? Take off from there. What do you know? Maybe a help with what do you know about a triangle with two congruent angles? Go ahead and talk about it there. Okay, and to even make it easier, maybe we're talking about triangle ABC and we say angle A is congruent to angle B. Okay? What do we know about a triangle that has two congruent angles? Alex? Okay, by the base angles theorem. Then we know that it has also, as Carlos said here, two congruent sides, which makes it isosceles. Okay? A scalene triangle, what's the definition of a scalene triangle? Good. A scalene triangle cannot have any congruent sides. Okay? Which proves in a scalene triangle. So this proves that a scalene triangle cannot have two congruent angles. Any questions there? Guys, it seems like a weird kind of roundabout way to do a proof. Okay? But it is helpful at times as you get into more complex stuff. All right. That, I believe, is the hard part of today's lesson. The next part I want you to do is I want you to take a look at this triangle. Let me see if I can just sketch one out real quick. All right, we'll kind of ignore that little extra piece. I'm trying to make it so very evident. We'll call this A, B, and C. Yeah, thank you. Tell your neighbor what the longest side is on that. Okay, it is not a right triangle. All right, so no hypotenuse in this triangle. Okay, what is the longest side? Okay, longest is A. Longest side, everyone agree, is AC? Okay, please tell your neighbor what the longest or the largest angle is. Okay, how many say angle C is the longest or the largest angle? How many say angle B is the greatest angle? How many say angle A is the greatest angle? Angle B, I would agree. Okay? Largest angle is angle B. Okay? Tell your neighbor what the smallest side is, or the shortest. Okay, shortest side is AB. Okay, everyone got that. Very good. Okay, what is the smallest, I forgot to finish that word, smallest angle? Is anyone's car alarm going off? Oh, sorry, they got it. Okay, don't worry about it. Must not have been ours. All right, what's the smallest angle? Angle C. Everyone agree? Okay, what do you know about the longest side and the largest angle and the smallest side and the smallest angle? Danica? Yeah, they're across from each other. They're opposite of each other. So if this is my longest side, this is my largest angle. It's opposite. Okay? If this is my shortest side, this is my smallest angle. They're opposite each other. Okay? In a triangle. Always. Always? Always. Always? Yeah, always. Just wanted you to know it's always true. Okay. That wasn't as hard as proof by contradiction, I don't think. Okay. All right, so we got that taken care of. One other piece I think we will go through. It is called the triangle inequality theorem. Now let me pause real quick before my mass of expo pins that don't work. Because there was a whole box of red pins that don't work. That's why they're all red.
Well, why would you buy a box of that?
Okay, so let me explain. First, I bought the set of pins, like planning to use them, and they didn't work. No, like, if you buy red pins, they sometimes work. They usually work. All right. Now, let's just say for a second I have a triangle, like this one. Okay? Oh, a side of a triangle. Let's go with that. There we go. How about that triangle?
I think that's supposed to be triangle.
Okay, so I need a third side. There we go. Now I have a triangle.
What?
Okay, let me put it together. Everyone agree that this is a triangle?
No, that is both sides. Not connected.
Okay, so if I connect them, can I connect them?
Yes. Oh.
Is that a triangle?
No.
Why will these three sides not form a triangle?
The same way. Well, you could have 178. The same.
Oh, well, Maddie, go ahead. Has nothing to do with them being red pens. Okay, so these two sides make up the length of the big side. Really is what you're saying. If this is 2/3, this 1/3, then 3/3 make up the whole length of the big side. Okay? I don't want to scare anyone away with fractions. So I can't make a triangle because this side doesn't make that side. What would I need to do to be able to make a triangle? Brandon? Okay, so if I add a pin. There we go. Good?
Yes.
Well, now you gotta add what has
That didn't work. Oh, single added to the single one. So if I like add it to this one. So, it has nothing to do with dating. Okay? There we go, and it has nothing to do with them being red. Hey, I made a triangle. Good? Hey, all right, that's a triangle. It's a red triangle. Okay? It's not a red triangle, it's a right triangle. It's what type of triangle? It's an isosceles. We just proved it's not scalene. Okay? So, there we've got it. What is the... Could I make a triangle if I add another pin to this side now? Okay, what are my guidelines for being able to make a triangle? Go ahead and talk to your neighbor about it real quick. Come up with a guideline. Once again, it has nothing to do with red pins. So, Drew, what is the rule?
So your longest. So you have your longest side. So your two other sides that aren't the long side have to be greater than the long. Side.
Good. So the two shorter sides have to be greater than the longest side. Or another way of saying it is any two sides of a triangle. Those two put together have to be longer than that one. Those two put together have to be longer than that one. Those two put together have to be longer than that one. Any two sides of a triangle, when added up, have to be greater than the third. Otherwise, you cannot make a triangle. Okay? That is the last theorem here. Okay? The triangle inequality theorem. And that's what that says. It's on page 187 of your student journal. The sum of the lengths of any two sides of a triangle is greater than the length of the third. Things that you may be like, well, duh, but you may not have thought of. Okay? That's just the truth. So AB plus BC has to be greater than AC. That's what that's saying. Okay? All right. Any questions there? Amazing fun? Yes, joyous, I can tell. All right. I need you to go ahead and turn to your extra practice in your student journal, please. So if we're looking at problem 13 on the extra practice, if you say 5 plus x has to be greater than 13, right? That means x would have to be greater than 8. The other route to go is 13 plus 5. Those two sides have to be greater than x, which means this would be 18 has to be greater than x. So we would have to have side lengths between, so side lengths between, I said that backwards, didn't I? 18 has to be greater than x, or x is less than 18. Okay? Between 8 and 18. Yeah.